Good morning, students. As we are discussing the divisibility rules, yesterday we started discussing the divisibility rule by 6 and we'll continue from there. I'm going to share my screen. Yes, I hope you are able to see my screen. Now, who want to explain these remaining numbers, whether they are divisible by 2, 3 and ultimately by 6 or not, can raise a hand. Surya, can you say this number 619, whether it is divisible by 2 or not?
Yes,
Why it is not divisible by 2?
okay.
Surya, there is a background noise. You sit in a quiet place.
Okay.
Rishikesh, can you explain why 619 is not divisible by 2? Rishikesh,
Sir,
why
sir,
619 is not divisible by 2?
sir, because unit digit is, sir, the divisibility rule of 2 is, in the units place we have to use even digits.
Very good. Is it divisible by 3?
Sir, is it? Yes, sir. Sir, no.
No, it's not divisible. Why?
Sir, sum of the digits, 3 divisibility rule is. 16 is not divisible by 3.
Okay. Then can I say that is divisible by 6 or not?
No.
No. Okay. Rishikesh, you can mute yourself.
Okay, sir.
Srivasu, can you tell me this number 1024 divisible by 2 or not? Srivasu?
Sir,
Srivasu, 1024, is this divisible by 2 or not?
sir,
Say yes or no.
divisible to.
Divisible. Why it is divisible?
Sir,
Why it is
so
divisible?
one place digit is 4.
Okay, very good. And is it divisible by 3? Is it divisible by 3?
No, sir.
Why it is not
No,
divisible by
sir.
3? Why it is not divisible? Why is it not divisible, Srivatsav?
Sir, one place digit is 4.
I'm not asking by 2, I'm asking by 3 now. 3, what is the divisibility rule? We need to check sum of digits, right?
Yes, sir.
What is the sum of digits in this number?
1024.
Sum of digits I want 1 plus 0 plus 2 plus 4. How much?
7.
7 is divisible by 3?
No, sir.
No. Can I say now this is divisible by 6? Can I say this is
No,
divisible
sir.
by 6? No. It is
No, sir.
divisible by both 2 and 3, then only divisible. Shivas, you can mute yourself. Pranay, can you tell me the next number? 216. Pranay,
Sir,
is it divisible by 2?
yes, sir.
What about 3?
Yes, sir.
What is the sum of digits we got?
9.
9 is divisible by 3.
Yes,
So what can I write under 6? Is it is divisible by 6 or not?
yes.
Yes, it's divisible. Very good. Pranay, can you tell me the next number also?
Yes, sir.
1296. Is it divisible by 2?
Yes, sir.
What about 3?
Yes,
Is it
sir.
divisible by 3?
Yes, sir.
Sum of digits, what we got?
18.
It's divisible. And what can I write for 6?
Divisible.
Divisible. If it is divisible by both 2 and 3, it is also divisible by 6.
6.
Surya, can you tell me this number? 1322.
Yes, sir.
1122. Is it divisible by 2?
Yes, sir.
And is it divisible by 3?
Yes, sir.
Check again. Sum of digits. Sum of digits is 7. Is 7 divisible by 3?
No, sir.
No. So what can I write under 6?
No. Not
Not.
divisible.
Okay. Surya, you can mute yourself. So the next divisibility rule we are going to discuss is for 7. So the divisibility rule by 7 we are going to discuss. Divisibility rule by 7. Suppose you have a number 12,345. I want to check whether this is divisible by 7 or not. What we need to do is separate the last digit. That means I have separated 5. Then double the last digit which is separated. So 5, if you double it, you will get 10. Subtract 10 from the remaining number. You will be getting 4, 2, 2, 1. In this remainder, again you subtract the last digit and double it. 4 into 2 is 8. Subtract 8 from this number, you will be getting 140. Separate the last digit again and double it. 4 2s are 8 and the remainder is 3. So the last digit, either it is 0 or any multiple of 7. Any multiple of 7. Then it is divisible by 7. So we can say 12,345 is not divisible by 7 because 3 is not divisible by 7. Is not divisible by 7. Let's take one more example. Suppose you take this number 3,21,244. Separate the last digit, double it. 4 into 2 is 8. Subtract 8 from this number, you will be getting 32116. Separate the last digit 6 and double it. 6 2s are 12. Now you subtract this. 3,211 minus 12. You'll be getting 3,199. Separate the last digit and double it. 9 into 2 is 18. Subtract. So you'll be getting 301. Separate the last digit and double it. 1, 2 times is 2. So 30 minus 2 we got 28. And we can see 28 is a multiple of 7. A multiple of 7. So we can decide 321244 is divisible by 7. So this is the way we are going to check whether it is divisible by 7 or not. 8, it is same as 4. Divisibility rule by 8. So we will check the number formed by last 3 digits. We are going to check whether it is divisible by 8 or not. If the number formed by last 3 digits, if it is divisible by 8, then the entire number is going to be divisible by 8. For example, we have a very long number like 750432400. Now, to check whether this number is divisible by 8 or not, we need not divide the entire number by 8. Just check the number formed by last 3 digits. We have 400. And we know 400 is divisible by 8. 8 5s are 40 and 0. So the entire number, we can say it is divisible by 8. Now, we'll take 2 more examples. Okay, let us check these three numbers. Who will explain these three? Raise a hand, I'll give you choice. Shanai, can you explain this question? Next one. Shanai, am I audible to you? Shanai? Is it Sahana or Sahasra? Sahana? Sahana, you're not audible. Pranay, can you explain the next number? Pranay, how can I check the next number whether it is divisible by 8 or not?
Sir, check last three digits.
So 725, is this divisible by 7 or not? Shall we do the division?
Yes, sir.
8 nines are 72 and we get 0, 5. So 8 zeros are 0. We got the remainder 5. So is this divisible by 8 or not divisible by 8?
Not using way.
Not divisible by 8. Why? Because we check this number formed by last three digits and we get it is not divisible. And what about Anvita? Anvita, can you put the next number?
Sir,
Yes.
sir, can you explain by 7?
When you joined Anvita,
Sir,
when did you join?
sir, now only.
You watch the recorded lecture again and you have doubts you can ask in class. Okay?
Okay, sir.
Himateja, can you explain the next question? Himateja,
Sir,
can you explain the next question?
yes, sir.
Yeah, tell me.
Sir, divisible by 8.
So for the next number, what we have to check?
We, we will check last three digits.
Last three digits. Is it divisible by 8 or not? We need to check. So shall we do the division?
Yes, sir.
8 twos are 16 and we got 7, 4. 8 nines are 72, remainder 2. So can I say this number is divisible by 8 or not?
Not
So it's
not divisible
divisible
by
by
8.
8. Okay, very good. And Srivatsav, how can we check the last number whether it is divisible by 8 or not? Srivatsav, how can we check the last digit, last number, whether it is divisible by 8 or not?
3 digit.
We have to check the
Sir,
last.
last 3 digit number.
Okay, we have to check by 8. 8 ones are 8 and this is 64. Whenever you take two digits, we must use 0, right? 8 eights are 64 and remainder is 0.
Yes, sir.
Now, can I say this number is divisible by 8?
Yes, sir, divisible.
Yes, divisible. Without checking the entire number, just by checking the last three digits, we have decided. Okay, Srivatsa, you can mute yourself. Now we are going to discuss the divisibility rule by 9. Divisibility rule by 9, we can say in two different ways. That is, if the digital root, if the digital root is 9, or we can say if the sum of digits, if the sum of digits is divisible by 9, then we can say the number is divisible by 9. So let's take some examples. Okay, these are the numbers that we are going to check whether they are divisible by 9 or not. First, let us check by digital root method. I already explained digital root for divisibility by 3. So similarly, we can do it for 9 also. So digital root method, I'll explain the first question. Until we get a single digit, we keep on adding the digits. That is 3 plus, 0 plus, 5 plus, 6 plus, 7 plus, 8 plus 2. So let us add this. 3 plus 0 is 3, plus 5 is 8, plus 6 is 14, plus 7 is 21, plus 8 is 29, plus 2 is 31. So in 31, there are two digits. Digital root means until we get a single digit, we have to keep on adding. So that is 3 plus 1 is going to be 4. This is not 9. So we can say that it is not divisible by 9. And next number. The next number is, let's add the all digits. That is 2 plus, 3 plus, 4 plus, 0 plus, 1 plus, 7 plus, 2 plus, 9. 2 plus 3 is 5, 5 plus 4 is 9, 0, 9, 9 plus 1, 10, 17, 19, and 28. So in 28 there is more than one digit, so add again all the digits until you get single digit. 2 plus 8 is 10. In 10 there are two digits, so 1 plus 0 is going to be 9. 1 plus 0 is going to be 1. So 1 is not 9, so it's not divisible by 9. So everybody have to involve in the class by raising hand and giving answers. Ritvik not giving answers. Abhiday not raising hand. Sudeshna sitting quiet in the class. Vaishnavi not raising hand. Rishikesh, Shanai, Varshita, Sabu. I think this is Purti. Sanvi, Lakshita, Jaivan. Everybody sitting quiet in the class. You don't want to give answers? Everybody must involve in the class by raising hand and involving in the discussions. Aditi, can you explain this? Aditi, can you explain the next question?
Yes, sir.
Yes, tell me.
Sir, 1 plus 3 plus 4 plus
3,
1 plus
4.
6 plus 3.
Okay, can you add the digits and tell me the sum?
1 plus 3, 4. 4
Yes,
plus 8.
yes,
8 plus 2, 9.
yes. What is 9 plus 6?
9 plus 10, 6, 15.
Yes. What is
15,
3?
3, 15.
15 plus 3, 18. Now we got single digit or more than one digit.
More than 1 digit.
So again we keep on adding the digits 1 plus 8. What is the sum?
1, 9.
When you get 9, is it divisible by 9 or not divisible by 9?
Divisible by 9.
Divisible by 9. Now Aditi, very good. You can mute yourself. Rishikesh, can you answer? Rishikesh, can you answer the next question?
Yes, sir. Sir, I can't see screen, sir.
Just wait a second. Sorry.
Sir,
1 minute, 1 minute. Rishikesh, I think you are able to see the screen now.
yes, sir.
Okay, Rishikesh, you can continue. How can we solve the next question, whether it is divisible by 9 or not?
Sir, 9 plus 7 plus 20. 2 plus
9
9
plus 7 plus 2 plus
plus 2 plus 1 plus 4 plus 4 plus 8 plus 1.
can you say the sum?
Sir, 36.
Okay, you already did that.
Yes, sir.
Okay, let me check 16, 18, 19, 8, 27 plus 9. Yes, 36 correct. And 36, there is only one digit or more than one digit?
We have more than one digit. We have to add again.
Yeah, 3 plus 6. And what is the final answer?
Sir,
Yes,
9.
9. And is it divisible by 9?
Yes, sir.
Yes. Okay. Very good, Rishikesh. You can mute yourself. I will tell you one
Okay.
shortcut than this. Okay. How can we check in more shorter way whether the number is divisible by 9 or not? Let's take the same examples. So the same examples I am going to consider. So here let us take. So this is the shortcut we are going to discuss. Easily we can check. So that is 3056782, and this is 234011729, and this is 134,163, and this is 97214481. Okay, now how can we check easily? The shortcut is, instead of going for addition, we are going for subtraction. So we can cut all the multiples of 9. See here, for example, 3 plus 6 will create 9. I can cut them, no problem. 7 plus 2 is 9. I can cut them. And finally, 8 and 5 is remaining. We know 8 and 5 sum is 13. In 13, we are going to cut 9. So what is remaining in this? 4 is remaining. So whenever there is 0 remaining, then it will be divisible by 9, or any multiple of 9 also can remain. So here 4 is remaining. 4 is remaining means it is not divisible. Similarly, I'll explain in second. Third and fourth, I will ask any student. Second one, I am explaining. So 9 is directly available. We can cut. And 7 plus 2 is going to be 9. So I'm going to cut 7 and 2. And similarly, 4 plus 2 is 7. 7 plus 2 is 9. We can cancel them. There is only one digit remaining. It is 1. So when 1 is remaining, it is not divisible. Either 0 should remain or any multiple of 9 should remain. Now, who will try to explain the next two questions in shortcut? Then, can you explain the third question in shortcut?
Sir, I am Harshadan.
Yes.
Sir, 3,
Yes.
6 plus 3 cut.
So 6 plus 3 is 9. We can cancel them. Next.
3 plus 7 and 7 plus 1, 8. Sir, 8 plus 1, 9.
Okay, we can cancel all of them.
Yes, sir.
So nothing is remaining. So it is divisible?
Yes.
Yes, it is divisible. Very good, Harshvardhan. You can mute
Sir,
yourself. Yes,
uh,
yes.
you can say method of 7 once.
Method of 7. I think you joined late, Harshvardhan.
Yes, sir.
You can watch the recorded lecture and any doubts you can ask me in the class.
Okay, sir. Sir, I 8 listened.
Okay, you have to, that's why attend the class on time, 6 o'clock.
Okay, sir.
Abhiday, can you explain the last question? Abhiday, you're not audible. Abhiday, you try to leave the class and join again. You're not audible to me. Sahasra, yeah, I think this is Pranay. Pranay,
Sir.
Pranay, can you explain this?
Sir, sir.
Yeah, tell me which digits to cancel.
Sir, 9.
9 is directly 9. Yes. Then
7, 2.
7 and 2 is some 9. We can cancel. Next.
1, 4, 4.
144 sum is 9. Very good. Next.
8, 1.
8 1. Everything got cancelled. So is it divisible by 9?
Yes.
Very good. And Pranay, that is the same shortcut can be used for 3 also.
Sir, yes.
The same shortcut can be used for 3 also. Let me write here. Same method. This cuttings method can be used for 3 also. Okay, let's take some numbers. Okay, these numbers we are going to check whether they are divisible by 3 or not. But when they are divisible by 3 or not in this method, now we can cancel any multiple of 3. So what are the single digit multiples of 3? Either we can cancel the sum 3, or we can cancel the sum 6, or we can cancel the sum 9. Why? Because 3, 6, 9, they are the single digit multiples of 3. So while checking by 3, so can be used for 3 also. Which digits we can cancel? 3 we can cancel, sum 6 we can cancel, sum 9 also we can cancel. So I'm explaining first question, remaining a last students. So first, 3 is directly available, I can cancel. 1 plus 2 together is 3, so I can cancel 1 and 2. And 6 is directly divisible by 3, so I can cancel. 4 plus 5 together is 9, divisible by 3. So everything got cancelled. This number is divisible by 3. So now those who are interested in giving answers for other questions, you can raise your hands. I'll pick some students. Some students are sitting quiet. Spurti, can you raise your hand? Spurti, can you raise your hand? Spurti. Spurti, you have to raise your hand. Sharath, you are not raising your hand. Sudeshna, can you raise your hand? Sudeshna? Sudeshna, can you raise your hand? Litiksha? Litiksha, can you raise your hand? Litiksha, am I audible to you? Nishil, can you raise your hand? Nishil? Nishil? Okay, Sudeshna is raising the hand. Sudeshna, can you explain the next question? Sudeshna?
Yes, sir.
Yeah, how can we do in cuttings method this question?
Sir,
Yes.
7.
Yeah, 7 plus 7, how much?
Sir, 14.
14 plus 7, how much?
21.
So 21 is a multiple of 3. Can we cancel these 3?
Yes, sir.
Similarly, the sum of these 3 also 21. Can we cancel?
Yes, sir.
Everything got cancelled. So is this number divisible by 3?
Yes, sir. No.
Okay, you can mute yourself. Nishil? Nishil, can you answer the next question? Nishil, can you answer the next question?
Okay, sir.
Okay, tell me which digits you can cancel.
Sir, 4, 3.
Why 4, 3 will cancel?
Yes.
Why 4, 3 you are able to cancel? Either you want sum 3 or sum 6 or sum 9.
Yes, sir.
First check the single digits. Any 3, 6, 9s are there? Any 3 is there? Any 6 is there? Any 9 is there?
Sir, 3 is there.
So we can cancel 3.
Yes, sir.
Then check now. There is no other 6 and 9 or 3. Then check any sum of digits is either 3 or 6 or 9.
Uh, Sir, 5.
Where 5 is coming? 5 there is no relation with 4, 3, 6, 9. 5 added with any other digit. Either you are getting 3 or 6 or 9. Tell me.
No, sir.
5 plus 4, what is that?
10 plus.
5 plus 4, how much?
5 plus 4, 9, sir.
9. Can we cancel 9?
Yes.
Then why are you not saying that? And now 8 plus 2, how much?
8 plus 2, 10.
In 10, maximum how much we can cancel?
1.
1. 1. Maximum we can cancel 9.
Yes, sir.
In 10, maximum we can cancel 9. In 10, 9 is gone. How much will remain?
1.
1. If 1 is remaining, is it divisible or not divisible?
Not divisible.
Not divisible. You have to listen to the class properly, Michelle.
Okay, sir.
Ritvik, can you answer the next question? Ritvik. Ritvik, can you answer the next question? Ritvik, you are not audible to me. Ritvik? Ritvik?
Sir.
Yes, you can explain the next question.
Yes, sir.
Yes, tell me which digits you want to cancel.
Sir, 9.
Okay, 9 I have cancelled. Next.
9, 2.
Come again.
Sir, 7 and 2.
Very good. 7 plus 2 is 9. We can cancel. Next.
Sir, 4 and 2.
4 and 2 sum is 6. Very good. Next.
8 and 1.
8 and 1. Very good. So nothing is remaining. So is it divisible or not divisible?
Divisible.
Very good. You can mute yourself, Ritvik. And
Okay, sir.
Sahasra. Sahasra. Sahasra, are you there?
Sir, I am Sahana.
Where is Sahasra?
Sir.
Sahasra is there?
Sir.
Sahasra is there or not?
Yes, sir.
Sahasra, good morning. Sahasra?
Sir.
Is Sahasra there or not?
Yes, sir, I am Sahasra.
Yeah, Sahasra, how can you solve this question?
Sir, 9 cancel.
Okay, we can cancel 9, 9, 9, 9. Now, what are the remaining digits?
2, 1.
2, 1. What is their sum?
3.
Can we cancel that?
Yes, sir.
Nothing is remaining. So, is it divisible by 3 or not?
Yes, sir.
Very good. So, you can mute yourself, Sahasra. So, we discussed up to the divisibility rule by 9 and along with the shortcut also. Now, we are going to discuss more divisibility rules starting from 10. So, that is divisibility rule by 10. Everybody knows this. If the last digit or the units digit or the ones digit is 0, then it is divisible by 10. Otherwise, not. So let's take 1124, 350, 647, 1297, 444, 588876430 and 9090909 12345 9872 and 12902. Okay, these numbers you have to check. Any one student have to complete all of them. So let me check who is that. Spurti not at all raising hand.
Sir,
Sharat,
my
wait. Sarana, mute yourself. Litiksha not raising hand. Sudeshna not raising. Samatvika not at all involving in the class. Samatvika, can you raise your hand? Samatvika, can you raise your hand? Samatvika, raise your hand. Vikram, raise your hand. Vikram, raise your hand. Vikram, there is a button, hand button. Using that, you can raise your hand. And Mayuk also not involving in the class, not raising hand. Vikram, can you explain the first question? 1124. Is it divisible by 10 or not? Vikram. Vikram, how to check a number is divisible by 10 or not? Vikram, are you there?
Yes, sir.
How to check a number is divisible by 10 or not?
Yes.
How to check whether a number is divisible by 10 or not?
Yes, sir.
How can you check? I'm asking. Just now I told you, no, Vikram, if the last digit is 0 is divisible by 10. Otherwise, it is not divisible by 10. Repeat it. Vikram, why are you not talking? Vikram, you repeat the statement. A number is divisible by 10 if the last digit is 0. Repeat the statement. Vikram, you're not audible to me. Mayuk, can you raise your hand? Mayuk, why are you not responding in the class? Mayuk, are you there? Mayuk, Mayuk, answer my question. Mayuk, you're not audible. Mayuk, you try to do one thing. Leave the class and join again. Sharat Chand is not at all raising hand. Litiksha Samatvik also same thing. Mayuk, can you answer now? Sharat, good morning. Sharat,
Sir,
Sharat, why are you not raising hand? I am calling your name these many times.
sir,
What happened?
sir, anything, sir,
Yes, tell me. What is the divisibility rule by 10?
sir, last digit 0
Okay, then.
is,
Now tell me 1124. This number is divisible by 10 or not?
sir, no,
No. Next number.
sir, yes,
Next number.
sir, no,
No. Why no?
sir, last digit 7,
Okay. You could say last digit is not 0. Okay.
yes, sir,
Number.
sir, no,
Say full statement not divisible by 10.
okay, sir,
Tell me.
sir, not divisible by 10,
Next number.
sir, not divisible by 10,
Next number.
sir, divisible by 10,
Next number.
sir, not divisible by 10,
Next number.
sir, not divisible by 10,
Next number.
sir, not divisible by 10,
Next number.
sir, divisible by 10,
Okay. So you gave all correct answers. So this is very a simple rule to remember. So Sharath, you can mute yourself. Next, we are going to discuss by 11. 11 is one important rule. Based on that, you'll get questions regularly. So how can we check whether a number is divisible by 11 or not? For example, I have a number 1, 2, 3, 4, 5, 6, 7. Okay. I want to check this number is divisible by 11 or not. What you need to do is, starting from right to left, you can select one number and you can drop one number. You can select one number and you can drop one number. You can select one, drop one, select one. Whichever you selected, you add one side, that is 1 plus 3 plus 5 plus 7. Whichever you dropped, you add them on the other side, 2 plus 4 plus 6. Find their sums. 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16. And find the sum of these three. 2 plus 4 is 6, 6 plus 6 is 12. Now for these two, you should find the difference. So the difference between 16 and 12 is 4. Here, either you get 0 or you get any multiple of 11, or you get any multiple of 11, then it is going to be divisible by 11. Otherwise it is not divisible. So because we got remainder 0, sorry, because we got remainder 4, then we can say that this number is not divisible by 11, is not divisible by 11. I'm going to take one more example like this. So let's take some bigger number, 603 873 864. I want to check this number is divisible by 11 or not. Now what I do is, starting from right to left, select one digit, drop one digit, select the digit, drop the digit, select the digit, drop the digit, select the digit, drop the digit, and select the digit. Selected digits, you find the sum one side, 6 plus 3 plus 7 plus 8 plus 4. Drop the digits, you find the sum separately, that is 0 plus 8 plus 3 plus 6. Now let us find the sum of this side. 6 plus 3 is 9. 9 plus 7 is 16. 16 plus 8 is 24. 24 plus 4 is 28. And here the sum is 0 plus 8 is 8. 8 plus 3 is 11. And 11 plus 6 is 17. Now what is the difference between 28 and 17? So 28 minus 17 is going to be 11. So because we got 11, what is the condition I said? Either it may be 0 or it may be any multiple of 11. 11 is a multiple of 11. Because we got 11, then we can say that the number, this number, the first number what we have taken, that is divisible by 11. Divisible by 11. Now I'm going to give some questions. So everybody have to solve. First copy these two. Then I'm going to give some questions. Everybody must involve in the class and try to give answers. So next a few questions we are going to discuss. Okay, these two questions, I want anybody from you to solve this. So raise a hand if you want to explain. Himateja, can you explain this question? Himateja,
Sir,
Himateja, can you explain this question?
yes, sir.
Yeah, tell me what we have to do.
Sir, we have to do
Yes, tell me.
drop one.
Yeah, I'm selecting two. And you remember one thing, starting from right to left, the selected places are called odd places and the dropped places are called even places. Okay, I selected two. So one I should select or drop. Himateja, I have
Sir,
selected two. So one I should select or drop.
one.
Yeah, one we have to select or drop.
Sir, 8.
Okay, next, yeah, next,
Sir, 0.
next.
Sir, 6.
Okay, selected digits you add one side, that is 6 plus 0 plus 8 plus 2. What is the sum, Himateja?
16.
16. Drop the digit you add on the other side. 1 plus 3 plus 1. What is the sum?
Sir, 5.
5. What is the difference between these two, Himateja?
Sir, 11.
11. When you get 11, it is divisible by 11 or not divisible by 11?
Divisible by 11.
Very good. It is divisible by 11. Okay, you can mute yourself, Himateja. Next question will be explained by Arush. Can you explain the next question? Arush.
Yes, sir.
Yes, tell me.
We have to take 5,
5. Yes.
drop 7,
Okay.
take 8,
Okay. Only tell me the digit which you are selecting.
5, 8,
8. Yes.
3,
Yes.
2,
2. Selected digits you add this side. 2 plus 3 plus 8 plus 5. What is the sum you are getting for this?
18,
18. Very good. And drop the digits you write here. 1 plus 2 plus 0 plus 7. What is the sum you are getting?
10,
10. What is the difference between these two? 10 and
8.
8. 8. So which digit we expect here? Either 0 or any multiple of 11, right?
Yes.
But we got 8. So is it divisible by 11 or not divisible by 11?
Not divisible by 11.
So it's not divisible by 11. It's not divisible by 11.
By 11.
Okay. So very good, Arish. You can mute yourself. Now up to 12 we discussed. Sorry, up to 11 we discussed. Now starting from 12, I'll tell you one method that is called co-prime method. So to understand this method, first we should understand what are co-primes. Co-primes are relative primes means. So first let us write that. What is the meaning of co-primes? Or they are also called relative primes. Co-primes are also called relative primes. So the definition of co-primes or relative primes is if two numbers are having only one as their common factor. So here only word is very important. Only one should be there as common factor and nothing else. Then they are called co-primes or relative primes. So let us take one example of 4 and 9. 4 I want to write the factors. What are the factors of 4? 1, 2, 4. 9, what are the factors? 1, 3, 9. Round up the common factors. Only one is common. Any other thing is common? No. So only one is common. So we can say that they are co-primes. For example, if I take 4 and 6, okay? So who will try to explain 4 and 6 is a set of co-primes or not? So let's ask Aditi. Aditi, can you tell me the factors of 6?
Sir,
Factors of 4 first. Aditi, what are the factors of 4?
sir, do you explain again?
Okay, see, first we have to write the factors of both the numbers and we find the common factors. If there is only one common factor, that is 1, then it is divisible by, then they are called co-primes. Only one should be common factor and nothing else. Can you tell me the factors of 4?
Okay, sir.
Tell me what are the factors of 4? Which numbers divide 4 exactly?
Which number divides
4 exactly.
4 exactly?
Is 1 dividing 4 exactly?
1.
1 divides every number, no?
Yes, sir.
Right, 1. What is the next number which divides 4 exactly?
4 exactly.
After 1, you check 2. Is 2 a factor of 4?
Yes, sir. 2.
Yes. After that, you check 3. Is 4 divisible by 3?
No, sir.
Next digit 4, you check. 4 is divisible by 4.
Yes, sir.
So write 4. You understood what do you mean by factors?
Yes, sir.
6, you write factors now.
6, sir.
Yes.
1,
Yes.
2,
2,
3,
3.
4 not, sir.
Okay.
5 not.
Okay.
6.
6. That's it. Okay. Now what I said, round up the common factors. Where are common factors here?
1,
1 is common. Very good.
2,
2 is common. Very good. That's it. Any other common factors are left?
mm, 3,
No.
sir.
Where is 3? 3 is there, but 3 is not there in the 4, no? It should be there both sides. Like 4, it should be there and 6 also there.
Okay, sir.
For both. Okay. Now what I said the condition, only one should be there as a common factor, but there is one extra common factor 2. So can we say that they are co-primes or not co-primes?
Sir?
They are co-primes or not co-primes? The condition is only one should be there as common factor, but there is extra 2 also common factor. So can we say that they are co-primes or not?
Not.
Not co-primes. Very good. You can mute yourself. Now you have to give one example on your own. Who will give me? Varshita, can you give another example of co-primes? Varshita, can you give me another example of co-primes? Varshita, you are not audible. Varshita, can you give me an example of co-primes?
Sir?
Yes,
Sir, 39, 15.
13 and 15. Okay. 13, what are the factors? 1 and 13. 15, what are the factors, Varshita?
1, 9, 15.
Is 15 a
Sir,
prime number?
sir, 1,
Yes,
3,
yes,
5,
yes.
and 15.
Yes. What are the common factors?
1.
One. Only one is there as a common factor. So can we say that they are co-primes? Yes. Very good, Varshita. Let me check with Lakshita. Lakshita, can you give any example for co-primes? Lakshita? Lakshita, am I audible to you?
Sir,
Lakshita, why did you join the class late today?
sir, I have joined on 6:10 only, sir.
10 minutes late now. You missed the divisibility rule by 7.
Sir, I have wrote in my book.
Okay, but the initial explanation you missed.
Sir, I have listened.
Divisibility rule by 6, all examples you listen.
Yes, sir.
Okay, can you give me an example of co-primes?
Sir, 3 and 3.
3 and 3. Very good, wrong answer. Why? Because 3, the factors are 1 and 3. 3, the factors are 1 and 3. 1 is common, 3 is common. I said only 1 should be common, but 3 is also common. So this is not a pair of co-primes. I want a pair of co-primes, Lakshita.
Sir,
Co-primes means there should be only one as the common factor.
8 and 6.
8 and 6, again wrong answer. 8, what are the factors, Lakshita?
Sir, 1.
Yes.
Sir,
Yes.
4.
Go in order. After 1, you check 2. Is 2 a factor of 8?
So 2,
Yes.
4,
Yes.
8.
Okay. And 6, what are the factors?
Sir, 1,
Yes.
2,
Yes.
3,
Yes.
6.
6, what are the common factors?
Sir, 1.
1,
Sir, 2.
2. That's it.
Yes, sir.
What is the condition for becoming co-primes, Lakshita? Tell me.
So just only 1.
Only 1 should be there as common factor. But here 2 also their common factor. So can we say that they are co-primes or not co-primes?
Sir, not co-primes.
I want an example from you which are co-primes. Tell me.
Mm,
Remaining also think I'm going to ask. Lakshita, I will come back to you. You till then you can get one answer with you.
okay, sir.
Aryan, can you give an example of co-primes? Aryan, Aryan, can you give an example of co-primes? Aryan, are you there?
Sir,
Yeah, can you give me an example of co-primes?
sir, 5, 6,
Okay, you took 5 and 6. 5, what are the factors, Aryan?
1,
Yes.
5,
5. 6, what are the factors?
1,
Yes.
2,
2,
3,
3,
6.
6. Okay. Now, which are common factors here? 1 and 1. There is only one common factor. They are co-primes. Now, Aryan, you have to use 6 and second number is your wish. Which number you will take and they should become co-primes? Tell me.
Sir, 13.
Okay, 6 and 13. 6 factors we have 1,
1,
3,
2,
6.
3.
13 factors are 1 and 13 and there is only one common factor. Yes, there is a set of co-primes. Very good, Aryan. You can mute yourself. And let us
Okay,
see
sir.
some patterns in the co-primes. The patterns in the co-primes is, so this is very important note point. Okay, that is any two consecutive numbers. First important point is any two consecutive numbers. What do you mean by consecutive numbers? They come one after the other, like 3, 4, 4, 5, 5, 6. Like any two consecutive numbers are always co-primes. So let's take 4 and 5. So we can easily check 4 factors are 1 to 4, 5 factors are 1, 5. There is only one common factors. Similarly, you can take 3, 4 also co-primes. Like that. 5, 6 also co-primes. You take any two consecutive numbers, they're always co-primes. And one more important point is any two, any two consecutive, any two consecutive odd numbers, any two consecutive odd numbers are also co-primes. You take any two consecutive odd numbers. For example, if I take 1, 3, they are co-primes. If I take 3, 5, they are also co-primes. If I take 5, 7, they are also co-primes, and so on. You take 7, 9, co-primes. You take 9, 11, co-primes. Like this. And co-primes and primes, there is no relation at all. Both the numbers may not be prime, but together they can become co-prime. See the first example. 4 is not a prime. 4 is not a prime number. 9 is not a prime number. 9 is not a prime number. But together they became co-primes. That means if they want to become co-primes, individually both of them need not be primes. They may be primes, may not be primes, but there is no relation at all. In case if they are prime, they can be co-primes. In case if they are not prime, then also they can be co-primes. Okay, one more important observation in co-primes is any two prime numbers are always co-primes or always co-primes. So for example, if I take 3 and 11, 3 is prime number, 11 is prime number, both are co-primes. 5 is prime number, 7 is prime number, both are co-primes. 13 is prime number, 97 is prime number, so both are co-primes, etc. So you take any two prime numbers, they're always co-primes. So any doubts in co-primes, you can raise your hand and ask, otherwise you can lower your hand. One by one I'm going to ask. If you don't have any doubt, you can lower your hand. Okay, we'll go with Surya. Surya, you have any doubt in co-primes? Surya, you have any doubt in co-primes?
No, sir.
No, you can lower your hand. I told no. If there is no doubt, you can lower your hand. Arshava, any doubts?
Sir,
Yes.
sir, I can then I don't have doubts, but give me chance to answer any question, sir.
There are no questions left, only doubts now.
Sir, I don't.
Okay. Those who don't have doubts, you can lower your hand. Jayvant, any doubts? Jayvant, any doubt? Jayvant, are you there?
Sir.
Yes, speaking. Any doubts?
No, sir.
Then why are you raising hand? I told you no, if there are no doubts, you can lower your hand. Aditi, any doubts?
Sir.
Yes.
Sir, last any two prime numbers are always
Yes.
co-prime numbers.
You take any two prime numbers, they will always become co-primes. Shall we check once?
Okay, sir.
See, first we have 3 and 11, no? Let's write all the factors of 3. 3, what are the factors? Because it is a prime number, it has only two factors, 1 and itself. Because 11 is a prime number, it has only two factors, 1 and itself. Now, what are the common factors? Only one, no?
Yes, sir.
Co-primes. Is it clear?
Okay, sir.
You take any two primes, they're always co-primes. Rishikesh, any doubts? Anvita, any doubts?
Sir.
Yes.
Sir, can you explain again?
What again? Prime numbers.
Yes, sir.
Anvita, you don't listen for the first time always. We took these many examples, Anvita. If you take any two numbers, you write factors of both the numbers, and if there is only one common factor, that is 1, and there are no other common factors, then they are called co-primes.
Okay, sir.
Any doubt? Particular doubt you can ask.
Okay, sir.
Sahasra, any doubts?
Sir?
Yes, any doubt?
Sir, no, sir. You said to bring right now that tab divisor.
Okay. Not now. You can talk to me later. No, no. Shanai, you have any doubts?
Sir?
Yes.
Sir, I హ్యాండిల్స్ బటన్ వచ్చినా లేకపోతే మీకు యాక్సెప్ట్ అయితే లేదు సార్.
Okay. Let me check in class today. Speak in English.
ఓకే సార్.
Shanay, I can see your hand raising. That's why I gave you a choice. It's visible to me. No problem. Litiksha, you have any doubts? Litiksha?
Sir,
Yes.
can you explain second one?
Second one means which one? The note point or the examples?
Examples.
Which one? 4 and 6 you're asking?
No, sir, not points.
Note points. Okay. Note points, the second one is any two consecutive odd numbers are always co-primes. You know odd numbers, Litiksha?
Yes, sir.
What are they? Tell me.
1, 3, 5, 7, 9.
Why they became odd numbers? Because they are not divisible by 2, right?
Yes.
You know odd numbers 1, 3, 5, 7, and so on. You take any two consecutive odd numbers. Consecutive ones, they have to come one after the other. 1 and 3 consecutive odd numbers.
Sir?
Consecutive ones, what, they come one after the other or not?
Yes, sir.
For example, if I take 1 and 5, they are not said consecutive odd numbers because in between 3 we missed, right?
Okay, sir.
Okay, that means any two consecutive odd numbers are always co-primes. Shivatmika, any doubt? Shivatmika. Shivatmika, you have any doubts?
No, sir.
Why did you raise a hand then? Okay, this is about co-primes. Now, using co-primes method, Pranay, any doubts? Pranay,
Sir,
yes, Pranay, any doubts?
sir, one consecutive odd number and one prime number are co-primes.
You're taking three numbers at a time.
Sir, no, sir, two numbers.
That means you are taking any two prime numbers.
Sir, no,
And
one prime number, one not a prime number. Consecutive number.
see, if you take one prime and one composite also, for example, let us take 5 and 10. 5 is a prime number. Pranay, 5 is a prime number.
Yes, sir.
10 is a composite number.
Yes, sir.
But they are not co-primes because they have a common factor 5. I hope you understood.
Yes, sir.
Is it clear?
Yes, sir.
Okay. Now we are going to continue our discussion of divisibility rules, but using the method of co-primes. So if you use the co-primes method, let me put the heading back here. Okay, co-primes method. Using co-primes method, how can we check whether a number is divisible by the given number or not? For example, I want to check the divisibility of a number by 12. Then what you do is 12 you try to write it as product of co-primes. So you cannot write 2 into 6. Why? Because 2 and 6 are not co-primes. We know why 2 and 6 are not co-primes. 2 factors are 1 and 2, 6 factors are 1, 2, 3, 6, and there is an extra common factor 2. So don't write like this. You write only co-primes. So can I write 3 into 4? Yes, 3 and 4 are co-primes. So 12 we can express it as a product of two co-primes. To check a number is divisible by 12 or not, you check by 3 and you check by 4. If a number is divisible by 3 and also divisible by 4, then it is divisible by 12. So let's take an example for this. So let us take this example 658,752. I want to check this number is divisible by 12 or not. So I need to check two times. Once I should check by 3 and again I should check by 4. So checking by 3, we know the shortcut, that is we can go for cuttings method. So any sum 3, sum 6, sum 9, I can do cuttings. So 6 is divisible by 3, I can do cuttings. Next, 7 plus 2 is 9, I can do cuttings. And 5 plus 5 is 10, 10 plus 8 is 18. 18 is divisible by 3, we can cut it. So nothing is remaining. Yes, it is divisible by 3. It is divisible by 3. Now we should check by 4 also. Checking by 4, everybody, I think you remember the method. Check the last two digits, the number formed by last two digits. 52, is it divisible by 4 or not? 4 ones are 4, 12. 4 threes are 12 and remainder 0. It's divisible by 4. So whenever a number it is divisible by both 3 and 4, then we can say it is divisible by 12 also. So I'm going to give one more example and everybody need to raise a hand for that and explain. So the question is this. Okay, we want to check this number is divisible by 12 or not. Who will explain? Raise a hand. Lakshita, can you explain how we can check it is divisible by?
Sir, I have not understand. Can you explain once again, sir?
See, 12 we can write it as the product of co-primes 3 and 4. Yes.
Yes, sir.
So we have to check by 3 and we have to check by 4. If a number
Yes,
is divisible by 3 and if a number is also divisible by 4, then it is also divisible by 12. So first we have to check by 3. How to check a number is divisible by 3, Lakshita?
sir, sir, sum of all the digits.
Sum of all the digits. But I told you today one shortcut. Do you understand the shortcut?
Sir?
Do you understand the shortcut?
Yes, sir.
What is the shortcut? Cuttings method.
Yes, sir, I have understood.
Okay, can you tell me which digits to cut?
Sir, first 6.
Okay, 6 is divisible by 3. Next.
Sir, and 5.
5 is not divisible by 3 now. Either the digits should be divisible by 3 or sum of digits also divisible by 3 we can cut.
Sir, 3.
Yeah, 3 we can cut. 3 divisible by 3. Next.
Sir, 1.
1 is not divisible by 3, Lakshita. Sum of 1 and 2. What is the sum of 1 and 2?
Sir, 1 and 2 is 3.
3. 3 is divisible by 3, no?
Yes, sir.
We can cancel 1 and 2 now.
Yes, sir.
Now we check.
Sir,
Any are possible.
5.
Yes?
Sir, 4 and 5 also. 4 plus 5 is equals to 9.
Very good, very good. We can cut. If nothing is remaining, so is it divisible by 9?
Sir, yes, sir.
Okay, we can say that it is divisible by, divisible by
3, 3.
to check this divisible by 4 or not. What is the divisibility by rule by 4, Lakshita?
Sir, last 2 digits has to be
Yes. So the last 2 digits is 56. Check it divisible by 4 or not. 4 ones are 4, remainder is 1 and take down 6. 4 fours are 16, remainder 0. Is it divisible by 4, Lakshita?
yes, sir.
So it is divisible by 3 and also it is divisible by 4. Can I say it is divisible by 12?
Yes, sir.
Very good, Lakshita, and you got the answer. So without doing the division by 12, we have checked the number is divisible by 12 or not. Okay.
Okay, sir. Okay, sir.
I'm going to give one more example. Other student, anybody have to check this. Let's take 760278135. Not 5. Let's take 2. Okay, this number I want to check whether it is divisible by 12 or not. Who will try to explain? Can raise a hand. Ritvik, Pranay, Jayavans, Aditi, Harish, Nushi. Harshavardhan, can you explain this?
Sir, may I explain this?
Yeah, Harshavardhan, yes.
Sir, 3 cut.
Okay, first divisibility by 3. You are saying 3 we have cancelled. Next,
6
6, very good.
and 7 plus 2.
7 plus 2, very good. Next,
Sir, 8 plus 1.
8 plus 1, very good. Next,
7 plus 2.
7 plus 2. Everything got cancelled. So is it divisible by 3?
Yes.
Yes, divisible by 3. Now the same number we are checking whether it is divisible by
4.
4 or not. What is the divisibility rule by 4?
32. It is divisible by
Divisible. So it is divisible by 4.
4.
So we checked by both 3 and 4 and it is divisible. Can I say the number is divisible by?
Yes, sir. It can divisible by 12.
Yes, it is divisible by 12. So I hope everybody understood the divisibility rule of 12. Next, 13, it's not there in your syllabus and you need not learn. Actually, if you want to remember divisibility rules, there are divisibility rules possible for almost all the numbers, even up to 100 and more than 100 also divisibility rules are there. We cannot learn all of them. They are very complex. Some numbers are very complex, but only remember the important ones given in the syllabus. 13 we are skipping, but 14 we can do because 14 is nothing but 14. How can we write it as product of co-primes? We can write 2 into 7. So check by 2 and check by 7. Then it is divisible by 14. Then 15 also.
Sir, I have a doubt. All
Yes,
numbers have
Harshvardhan.
divisibility rules.
Come again. Come again.
All numbers have a divisibility rules up to
Yes,
100.
almost all the numbers have divisibility rules, but they are very complex. Some numbers are very complex.
Sir, so we want to learn only our syllabus.
Only important numbers given in the syllabus. Okay.
Okay, sir.
So next by 15. How to check a number is divisible by 15? How can you write 15 as a product of two co-primes? We can write 3 into 5. So check the number is divisible by 3 or not, and check the number is divisible by 5 or not. Then it is divisible by 15. Then 16. So 16, there is an interesting rule, that is, this is 2 power n pattern. This is 2 power n pattern. What is 2 power n pattern? I'll tell you. See here, 2 power 1 is 2. 2 power 1 is 2. 2 power 1 is 2, and that's why we check last one digit. We check last one digit. 2 power 2 is 4, and we check last two digits. 2 power 3 is 8. What do you mean by this power? 2 power 3 means you multiply 2 3 times. 2 2s are 4, 4 2s are 8. So it's divisible by 8 or not. We check last three digits. And now 16. 2 power 4 is 16. 2 multiplied 4 times. 2 2s are 4, 4 2s are 8, 8 2s are 16. So we can check last four digits. So how much big number also given to you, but you need not divide everything. So you can check only last four digits. For example, you have very big number 9701234560234. You have to check this is divisible by 16 or not. You need not divide the entire number. You just check the last four digits number divisible by 16, then the number is divisible by 16. And this pattern continues. 2 power 5 is 32. So to check the divisibility, we can check last five digits, and this pattern will continue. Okay. So this is called 2 power n pattern.
Sir, we want to check the divisibility rule of 16 means 2 power 4. Last
Yeah.
4.
2 power, because 16 is 2 power 4, we check the last four digits of the number. If it is divisible by 16, then the number is divisible by 16. Same like 4 and 8. Harshvardhan, it is same as 4 and 8. For 4, we check last two digits, no?
Yes.
For 8, we check last three digits, no?
Yes.
Similarly, for 16, we check last four digits. Okay?
Sir, we want to divide that digit with 2.
Not 2, 16.
Means we got the answer.
Whatever number we are checking, with that number we have to divide. Okay?
Okay, sir.
17, we'll skip. Harshvardhan, you can mute yourself. 17, we can skip. 18. How can we check 18? 18, you can write it as a product of two co-primes. Don't write 3 into 6. If you write 3 into 6, you'll get wrong answers, because 3 and 6 are not co-primes. They have a common factor 3. So don't write like this. You want to write a set of co-primes. So I can write 2 into 9. Yes, 2 and 9 are co-primes. So check the number is divisible by 2 or not, and check the number is divisible by 9 or not. If it is divisible by both of them, then it is divisible by 18. 19 we skip, and 20. 20, how can we write the product of two co-primes? We can write 4 into 5, because we know consecutive numbers are co-primes. So if a number is divisible by 4 and if a number is divisible by 5, then it is also divisible by 20. 21, we can check 3 into 7. If it is divisible by 3 and if it is divisible by 7, it is divisible by 22, 21 automatically. Then 22. 22, we can write 2 into 11. We know 2 divisibility rule, we know 11 divisibility rule. If it is divisible by both of them, then it is divisible by 22. 23 we skip, and 24. 24 we do like this, 3 into 8. So 3 and 8 are co-primes. We know the divisibility rule of 3 and we know the divisibility rule of 8. A number is divisible by 3 and a number is divisible by 8. It must be divisible by 24. And next 25. 25, this is also 5 power n pattern. This is 5 power n pattern. See, 5 to the power 1 is equal to 5. We check last one digit. We check last one digit. And what are the digits that we will search? 0 or 5. 5 to the power 2, that means 5 multiplied by 5, you get 25. So we check last two digits. We check last two digits. And the last two digits are either it may be 00, or it may be 25, or it may be 50, or it may be 75. And next 5 cube. 5 cube is 125. 125 also there is a divisibility rule. We need to check last three digits. And what are the last three digits that we will search? Either it may be 000, or it may be 125, or it may be 250, or it may be 375, or it may be 500, or it may be 625, or it may be 750, or it may be 875. If any three digits are at the end, last three digits, then it is divisible by 125. So there is a pattern. 5 power 1, we check last one digit, either 0 or 5. 5 power 2, 25, we check the last two digits. If the last two digits are either 0025, 5075. For example, I want to check this number 117225 is divisible by 25 or not. Check the last digits. Last digits 25 is there, so it is divisible by 25. I want to check one more number, that is 253075. This number is divisible by 25 or not. Last two digits, yes, it is divisible by 75, divisible by 25. So these are the divisibility rules, and after that also we have many divisibility rules, but these are the important ones you have to concentrate in Sainik syllabus. Okay, so any doubts in this discussion, you can raise the hands. I am going to clarify your doubts. Raise the hands if you have doubts. If you don't have doubts, just lower your hand. Surya, doubt. So Sudeshna scrolled up and right. Okay, everybody is having doubts. Now I am giving you one by one to speak and ask your doubts. Surya, what is your doubt? Surya.
Sir,
Yes, Surya.
sir, is 16 divisible to 4?
Okay.
Sir, you took last 4 digits, why, sir?
Why? Because 16 is nothing but 2 power 4, no? What is the power? What is the
Sir,
4? So that's why you have to check last four digits.
sir, means why did you write 2 square and to the power of 1, 2 cube?
Yeah, that you have to remember up to 32. And even this will continue after 32 also.
Sir, say an example to 2 square.
See, what you need to do is, so you want the exact rule. Suppose this number only we are taking, and you want to check whether this is divisible by 16 or not. Okay? You separate number last four digits. Okay?
Okay, sir.
We write it like 970123456, and after that 0000 plus 0234. Can you separate like this?
Okay.
Last four digits are zeros. Can you erase? Can you erase those four zeros and write multiplied by 1 followed by four zeros like this?
Okay.
Yes. Now this 1 followed by four zeros is nothing but 10 into 10 into 10 into 10, right?
Okay.
In every 10 there is a factor of 5,
Okay.
and in every 10 there is a factor of 2.
Okay.
So 2 into 2 into 2 into 2. Definitely 16 will be a factor of this number.
Sir, why don't you take 2 digits?
That's what I'm checking now. If the last four digits are 0, then it is definitely divisible by 16. That's why we skip that part and we check only this part. Okay.
Okay, sir.
Next, any other doubts? Aditi, you have any doubt? Aditi, why did you call me? Don't call me in the class. You can ask me doubts here only. Aditi,
Sir,
Aditi, why did you call me?
sir, father said I will leave at 7:30.
7:30. Where are you going?
Sir, because my mom late for school.
7:30, but you will miss the class, no? Even if you come late, no problem. 15 minutes. At least you can come, try to come by. Oh, for your father, it will be late. Aditi,
Sir.
for your father, it's going to be late.
Yes, sir.
Okay, no problem. Then what we can do, you can just last half an hour part you will be missing, no? That you can watch in the recorded lecture, and any doubts you can ask me later. Okay?
Okay, sir.
You are allowed to leave at 7:30.
Okay, sir.
Any doubts?
No, sir.
Okay. You have any doubts in this discussion?
No, sir.
Okay, you can mute yourself. Aryan, any doubts?
Help, sir.
Yes.
Sir,
Yes.
sir, your voice is stammering
Aryan, am I audible clearly now?
now.
Now tell me what is your doubt?
Sir, when you were explaining to Sister Lakita, it's my tab said internet connectivity or something. I
Okay.
did not understand.
Which one you didn't understand?
Co-friends.
Co-primes. Co-primes is very simple now. If two numbers are having only one as common factor and there are no other common factors, they are called co-primes.
Sir,
Yes? Yes, Aryan?
sir, you wrote me about co-friends before this.
You want the last three properties? These three?
Yes, sir.
Okay, first one, what is that? Any two consecutive numbers are co-primes. You know that, right?
Yes, sir.
You take any two consecutive odd numbers also, they are co-primes always.
Yes, sir.
And you take any two prime numbers also, they're always co-primes.
Sir, prime numbers.
Any two prime numbers you take, they're always co-primes. Okay?
Okay, sir. That's it, sir.
That's it. That's it. They are the
Okay.
properties.
Okay, sir.
Any other doubts left? Harshvardhan, your doubt?
Sir,
Yes.
sir, I have a doubt in pi n pattern.
Come again?
Pi n pattern.
It's not 5n. It is
I
5
have,
to the power n. Yes.
sir,
See, 5 to the power 1 is 5. So
sir,
because the power is 1, we check the last digit. And what should be there in the last digit? Either 0 or 5. And 5 square is 25. Because the power is 2, we check the last two digits. That is 00, 25,
sir,
50, and 75.
so it should be last two digits should be
Last two digits only.
25.
Yes, yes, last two digits only.
And
It may be it may be
can
00, it may be 25, it may be 50, and it may be 75. Then it is divisible. Okay?
and 5 cube will be 125 multiples, last three digits.
Yes, 120. Why 125? Because 5 cube is 125. Okay?
I understand, sir.
Okay. Next,
Sir,
Vishwajit, you have any doubts? Vishwajit?
Sir.
Yes.
Sir, I not wrote.
You can. When did you join? Can I know the time?
648.
6:40. When class starts, Vishwajit?
Sir.
6 o'clock, no?
Yes, sir.
Whatever part you missed, watch the recorded lecture and you can write the notes. I'll check your notes today. Okay?
Okay, sir.
Anvita,
No.
Anvita, have any doubts?
Sir,
Yes.
sir, can you explain 16 divisibility rule?
The 16 divisibility rule is following one 2 to the power n pattern. 2 to the power 1 is 2. Because the power is 1, we have to check the last one digit divisible by 2 or not.
Sir,
Yes, 2 square is 4. 2 square means what? 2 multiplied by 2. 2 multiplied 2 times. That
yes, sir.
if the last two digits is divisible by 4 or not. If the
Okay,
pattern continues, 2 power 3 is 8. We check the last three digits is divisible by 8 or not. 2 power 4 is 16. Any big number may be given. We don't check the all the digits. We check the four is divisible by 16 or not. If it is divisible, the number is divisible. Otherwise, it is not. Okay.
okay, sir.
Next, Jaiwant, you have any doubts? Jaiwant, Jaiwant, you have any doubt? Jaiwant, you are not audible. Leave the class and join again. Shivatmika, doubts? Shivatmika. Yes, Shivatmika, you have doubts?
Sir, can you explain 20? Fifth one.
25 divisibility rule, I already explained to Harshvardhan, right? It is following 5 to the power n pattern. 5 power n is 5. So the last one digit. The power is 1, no? We check last one digit. Either it may be 0 or 5. 5 square is 25. Because the power is 2, we check the last two digits. What should be there in the place of last two digits, Shivatmika?
Sir.
Either 00 or 25 or 50 or 75. If any two digits are there, then it will be divisible by 25. Clear? Similarly, 5 cube also 125. That's why we check last three digits. Okay, Shivatmika?
Okay, sir.
Next, Sriyansh, you have any doubt? Sriyansh, when did you join the
Sir.
when did you join the class?
Sir, now, sir.
How are you feeling now? Are you going to come today?
Sir, no, sir. I have so fever, sir.
Yeah. So you are not fine.
Yes, sir.
Get well soon, Sriyansh.
Okay, sir.
Yeah, tell me whatever doubts you have.
Sir, I didn't understand 25th, sir.
See, 25, you know this now already.
Sir, in class you said only 00255075.
125, I told you in fractions. Do you remember? Whenever the denominator is 125,
Yes,
we convert easily into decimals. I asked you to remember 125 table.
yes, sir.
125, this is nothing but 125 table only, no?
Yes, sir.
Because 125 is 5 cube, the last three digits must be either 000, 125, 250, and so on. This pattern continues for the next number also. 5 to the power of 4 is 625, right?
Yes, sir.
The last four digits we can create the multiples.
Okay, sir.
Okay. Next, Arvita, you have any doubts? Anvita, you have any doubts?
Sir, no, sir.
No, why did you raise a hand then? Titiksha, doubts?
Sir,
Yes, Titiksha.
sir, can you explain me 16th one?
16, whenever the other student are asking, I explained two times. At that time, you are not listening.
Sir.
It is their doubt why I should listen. I will do time pass. No, whenever other students also asking, you can listen to that same doubt that you are having, right?
Yes, sir.
Then why don't you listen two times? I explained. So 2 cube is 8 because the power is 3. You check the last three digits whether it is divisible by 8 or not. Suppose 2 power 4 is 16 and the last four digits whether it is divisible by 4 or 16 or not we need to check. Whatever is the power, that many digits we have to check. Okay?
Okay, sir.
And Harshavardhan doubts.
Sir,
Yes.
sir, you can create poll or give a non Sainik book previous year papers.
Yeah, yeah, I'll create, but let me clarify the doubts from this explanation first.
Okay,
You-
sir.
Do you have any doubts on the screen?
Mass. Today total mass, no other subject.
Let me check because if you complete these doubts, no, then we can go for the other subjects.
Okay, sir.
Jaivan, do you have any doubts? Jaivan,
Sir,
yes, then.
sir, is the 5 power n pattern will continue?
Yeah, that will continue forever. 5 power 4, 5 power 5, and so on. But nobody will ask you after 5 cube because it's really big. If you go for 625, no, so many multiples you're going to get. These are the only important ones regularly asked in the exam. Okay.
Oh, okay, sir.
And Lakshita, you have any doubts? Lakshita,
Sir,
yes, ma'am.
sir, can you scold up some?
You can watch the we recorded lecture and write the previous thing, ma. If you missed anything,
Okay, sir.
class.
Sir, sir, after this match, can you say GK?
Yes, yes. GK we go for. If it is completed now quickly, then we can go for GK.
Okay, sir.
That's it. I think all the doubts are cleared.
Yes.
Okay. Now let us discuss some GK questions. Okay, all of you ready for the polls? Yes, GK questions. Everybody, be ready. So GK, we were discussing sports. I think the Asian Games. Let us complete that part today. Yeah, Asian Games. I think this question was completed. When was cricket introduced for the first time in Asian Games? That is completed previously. And next question is this: which country won the most gold medals in kabaddi in the Asian Games? I'll give 1 minute time. Don't message in the chat box. You can participate in the poll only. Just wait a second, ma. Okay, all of you, you can participate in the poll now. Poll started. Which country has won the most gold medals in kabaddi in the Asian Games? A. Pakistan, B. Iran, C. India, and D. Bangladesh. 30 seconds left. Yeah, most of the students gave the correct answer. It is option C, that is India. Okay, let us see the explanation also. India is very good in kabaddi. Even the previous edition of the first edition of the World Cup, Kabaddi World Cup, India won. I think just last month only. Last month only it happened in India. So India won the World Cup in kabaddi also. So kabaddi India is very good, and in Asian Games also most medals for kabaddi is won by India. India has been the most successful country in kabaddi at the Asian Games, winning multiple gold medals since the sport was introduced in 1990. From 1990, in Asian Games, kabaddi was introduced, and from then, India won the highest number of medals in kabaddi. Next question is waiting for you. In which Asian Games was the Olympic motto "Ever Onward" first used? Olympic motto "Ever Onward" is first used from which year? 1 minute time. Poll started. In which Asian Games was the Olympic motto "Ever Onward" first used? 30 seconds left. Ten seconds. Yes, most of the students got correct answer. 2 students gave D, 7 students gave C, and 9 students gave A. And the correct answer given by many students, that is 10 students gave the correct answer B, 1958. So the answer is 1958. The motto "Ever Onward" was first used in the 1958 Tokyo Asian Games. Tokyo is the capital of Japan. So Tokyo Asian Games 1958, the first time this motto was used. Next question. Who holds the record for the most gold medals won by an athlete in a single Asian Games? Not all the Asian Games together, single edition of Asian Games. Who has the record for scoring most number of gold medals? I'm going to create the poll. Poll started. Who holds the record for the most gold medals won by an athlete in a single Asian Games? Not all the Asian Games, all the years together, in a single edition of Asian Games. Who has the record of scoring highest number of gold medals? Ten seconds left. And time up. 4 students said A, wrong answer. 10 students said B, wrong answer. And 7 students said C, wrong answer. Correct answer is D. 8 students give the correct answer. Let us see the explanation. Rikako Iki. Japanese swimmer Rikako Iki won 6 gold medals in the 2018 Asian Games, making her the most successful female athlete in a single edition. So, a female Japanese swimmer, that is in which competition? Swimming competition. He has a record of scoring highest gold medals in a single edition 2018. So this is from Asian Games questions. Now let us change the topic, that is food deficiency diseases in food. Okay, all of you. This question came in 2023 Sainik school exam. The deficiency of which of the following vitamins causes rickets? Vitamin A, vitamin D, vitamin C, and vitamin B12. I'm going to give the same vitamin names as the options. You can go for. So, deficiency of which vitamin causes rickets? I'm not typing the entire question. I'm just saying rickets. Rickets is caused by the deficiency of, is it vitamin A, is it vitamin D, or is it vitamin C, or it vitamin B12? Rickets is caused by the deficiency of which vitamin? Okay, I'm giving 1 minute time. Poll started. All of you participate in the quiz. That is rickets. It is a disease caused by the deficiency of which vitamin? Is it vitamin A, D, C, or B12? They are not option names A, D, C, B12. That is vitamin A, vitamin D, vitamin C, and vitamin B12. 30 seconds left. Twenty seconds left. And time up. So let us see the results. One student said option A, vitamin A, wrong answer. and 5 students said vitamin C, wrong answer. 6 students gave the answer vitamin B12, wrong answer. The correct answer is vitamin D. 18 students. So majority of the students gave correct answer. So let us see the explanation. Rickets is a disorder caused by the lack of vitamin D, calcium, or phosphate. It leads to the softening and weakening of the bones. Bones will become weak. Vitamin D helps the body regulate calcium and phosphate levels. So, vitamin D, our body can prepare freely without taking any food also. Just standing in the sunlight in the morning, our body is able to prepare vitamin D on its own. That's why you have to expose your body in the early morning sunlight. So, next question. Which vitamin deficiency causes night blindness? All of you try to participate in the quiz. Which vitamin deficiency causes night blindness? Now there are options, not vitamin names. Vitamin option A, option B, option C, and option D. And the question also I have typed. So 1 minute time. Poll started. Which vitamin deficiency causes night blindness? Option A, vitamin A. Option B, vitamin B12. Option C, vitamin C. And option D, vitamin D. Thirty seconds left. Ten seconds. And time up. No students gave D. 3 students gave option B, wrong answer. 7 students gave option C, wrong answer. Majority of the students gave correct answer. 19 students gave correct answer. It is vitamin A. Let's see the explanation. So vitamin A deficiency leads to night blindness. So whenever it is dark, they are not able to see properly because of the deficiency of vitamin A. So a condition where the eyes struggle to adjust to dim light. So dim light, the eyes are not adjusting themselves to see the dim light conditions. Next question. What is a deficiency disease caused by lack of vitamin D? Lack of vitamin D. What is a deficiency disease? I hope question repeated. Let us see how many of you remember. I'm going to start the poll. At least repeated question. I should not see any student giving wrong answer. Let us see how many of you are attentive in class. What is the deficiency disease caused by the lack of vitamin D? Scurvy, rickets, beriberi, pellagra. Time up, and let us see. Still, 3 students gave wrong answer after the question repeated also. vitamin the option D is given by one student and option C is given by two students. Both are wrong. 26 students, majority of the students gave correct answer. Rickets, we already discussed just now. The first question only it got repeated. So rickets is a disease that weakens bones, making them soft and deformed due to insufficient vitamin D. Next question, lack of vitamin C in the diet causes which disease? Lack of vitamin C in the diet causes which disease? Poll started. Lack of vitamin C in the diet causes which disease? Option A, rickets. Option B, scurvy. Option C, night blindness. And option D, goiter. Thirty seconds left. Five seconds left. And time up. So no student gave option A, rickets, because just now we discussed it's caused by vitamin D. Okay, at least you remembered now. Three students gave option C, night blindness is caused by vitamin A, which is already in the previous questions. Some students are not following the previous questions, only remembering. Goiter is because of iodine deficiency. So scurvy, we got the correct answer. Lack of vitamin C causes scurvy, leading to bleeding gums. So vitamin C deficiency leads to scurvy, causing bleeding gums, joint pain, and weakness. And vitamin C is available in citrus fruits like lemon, orange, etc. So vitamin C boosts your immune system, and also vitamin C, wherever vitamin C are present, the sources, you cannot heat them and eat. Why? Because vitamin C easily gets lost by heating. You have to eat it raw. So whether it may be lemon or whether it may be orange, etc., those that are having the sources of vitamin C, don't heat and consume. If you heat, vitamin C gets lost easily. Next question. Which mineral deficiency causes goiter? So while I was explaining the previous question. I gave the answer already, but let us see how many of you remember. Goiter is caused by the lack of what? Lack of which mineral? 1 minute. Poll started. Which mineral deficiency causes goiter? Is it calcium, iodine, iron, sodium? Last 10 seconds. And the time over. Two students said option D, wrong answer. Four students each voted for A and C, they are also wrong. And majority of the students gave correct answer. 19 correct responses for option B, that is iodine. So lack of iodine causes goiter. Iodine deficiency results in goiter, an enlargement of the thyroid gland. Where is thyroid gland present? In your neck. So the neck appears to be swollen, affecting hormone production. So hormone production will be imbalanced and the life processes will be getting disturbed. Either the person will become too fat or too lean. Next question. Beriberi is caused due to the deficiency of which vitamin? Is it vitamin B1, B2, B6, B12? Beriberi is caused by the deficiency of which vitamin? Let me create the poll. Poll started. Option A, vitamin B1. Option B, vitamin B2. Option C, B6. And option D, B12. Beriberi is caused by the deficiency of which vitamin? Fifteen seconds left. 5 seconds. And time up. One student gave option C, vitamin B6. It is wrong. 4 students gave option B, wrong. 9 students gave option D, wrong. And majority of the students gave correct answer. 14 students voted for option A. Vitamin B1 deficiency causes beriberi. Beriberi occurs due to a lack of vitamin B1, that is thiamine. What is another name of vitamin B1? Vitamin B1 is also known as thiamine, remember, leading to weakness, nerve damage, and heart issues. So these are the symptoms, these are the effects of beriberi. Next question, which deficiency disease is linked to a lack of iron? Next question, which deficiency disease is linked to lack of iron? I'm creating the poll. Is it option A, rickets? Is it option B, pellagra? Is it option C, anemia? Or is it option D, scurvy? Yes. So 1 minute poll started. Which deficiency disease is linked to a lack of iron? Rickets, pellagra, anemia, scurvy. 20 seconds left. Ten seconds. And time up. No students gave option A. One student selected B. And 6 students said scurvy. Those 6 students who said option D, scurvy, we already discussed scurvy is caused by which deficiency? That is not because of iron. The correct answer is anemia. 21 students gave correct answer. So let us see. Anemia. Iron deficiency leads to anemia, which causes fatigue. That means even by small work, you will feel a lot of pain, body pains, pale skin, and weakness due to low red blood cell production. So RBCs, red blood cells production will be lowered. These are the effects of anemia. That is due to the lack of iron. So where iron is present in the which sources of food? Milk, it is present. You can say brinjal. Brinjal is present. Next question. Pellagra is caused by a deficiency of which vitamin? Pellagra is caused by the deficiency of which vitamin? Ready for the quiz? One minute quiz started. Pellagra is caused by a deficiency of which vitamin? Vitamin B3, B6, B9, B12. So all these types of vitamin B together, they are called vitamin B complex. But in vitamin B complex, we have different vitamins. Which particular vitamin deficiency causes pellagra? This is the last question in today's class. After that, we are going to end the class. Last 5 seconds. And time up. So let us see the results. 2 students voted for C, vitamin B9, wrong answer. 3 students voted vitamin D, B12, wrong answer. 11 students voted B6, also wrong answer. And 11 students gave B3. That is the correct answer, option A. Pellagra results from a deficiency of vitamin B3. What is another name of vitamin B3? That is niacin. Earlier we discussed another name of vitamin B1, and this is vitamin B1, B3. The another name is niacin, leading to diarrhea, dementia, and dermatitis. Okay, so they are related to maybe skin. So this is the last question of today's class. So all the students, you actively participated in today's class and clarified your doubts by raising hand and speaking to me. Very good. So continue like this and attend all the classes and get a good revision of Sainik School exam for 2 months. Okay. So all of you, please leave a feedback in the chat box and you can leave the class. You can give feedback of today's class and you may leave the class now. All of you. All the students, you may give the feedback in the chat box and you may leave the class now.